In modern machines, the transfer of energy from the engine to the working organ is carried out by various devices. Here is an example of a mechanical device. Hydraulic transmission operates here, and pneumatics operates here. The mechanisms that transfer energy from the engine to the executive are called transmissions. The motor shaft has a rotational motion. The movement of the working bodies can be transformed into reciprocating or oscillatory. Now we see examples of various types of mechanical transmissions. In some cases, the motor shaft is combined with the shaft of the working body. In most machines and mechanisms, there are gears between the engine and the working body. What are they for? They are necessary to change the speeds and directions of movement of the actuators of machines. To set several mechanisms in motion from one engine. To provide a greater torque of the executive body than the motor shaft. And in those cases when the working bodies of the machine perform a different kind of movement than the engine shaft. Mechanical transmissions can be divided according to the principle of operation: friction transmission, belt or gearing, gear transmission, chain. The torque is transmitted when rolling bodies contact due to the friction forces between the rollers. The working circumferential force should be less than the friction forces between the rollers, otherwise there will be slipping. The gear ratio is equal to the ratio of angular velocities and is equal to the inverse ratio of the diameters of the rollers, taking into account the sliding coefficient. The leading roller can equally be either large or small. The gear ratio for such pairs of wheels is not regulated. Mechanisms with an adjustable gear ratio are called variators. They allow you to smoothly change the speed of rotation of the driven shaft. Look, the drive shaft rotates at a constant speed, and the speed of the driven shaft changes. In technology, various designs of variators are used to regulate speeds. They can be not only with parallel axes, but also with intersecting ones. In such a variator, the direction of rotation of the driven shaft also changes. In all these cases, the wheels of the friction gears are in contact and the transmission of torque is carried out by friction. The advantage of friction gears: simplicity of design, smooth motion transmission, noiselessness, stepless speed change. And the disadvantages? The variability of the gear ratio due to slippage, high pressure on the shaft supports and significant wear of the rollers. Gear mechanisms are the most common group of mechanical gears. They are used in a wide range of power and working conditions. The advantages of gears over all other types are the immutability of the gear ratio, long service life and high efficiency. When engaging, the teeth should roll smoothly. The involute shape of the lateral surfaces of the tooth meets this requirement. The smaller gear wheel is called a gear. The gear ratio is equal to the ratio of the number of teeth of the wheel to the number of teeth of the gear. In addition to straight-toothed wheels, slant teeth are also used. Double bevel-toothed wheels or chevron wheels are also used. The advantages of oblique gears compared to straight teeth are that they withstand heavy loads and work more smoothly. In bevel gears, the geometric axes of the wheels intersect. Among the new types of gears, the Novikov engagement is interesting. In this engagement, the gear teeth are convex and the wheel teeth are concave, so the contact area of the teeth increases and the load capacity of the transmission increases significantly. Gears can be with parallel shaft axes and intersecting, with external engagement of the teeth of the wheels and internal. And according to the number of steps, single stage and multi-stage. Gears are widely used in gearboxes and gearboxes. The gearbox is a gear transmission made in the form of a separate unit. Consider a simple example. The car is going uphill. The driver switches the speed. And for what? To increase the torque of the wheels. Let's consider the schematic diagram of the gearbox device. It serves to change the gear ratio, that is, to increase or decrease the torque. The design of the gearbox depends on its purpose. In metal cutting machines, gearboxes are often called gearboxes. Gearboxes also make it possible to change the direction of rotation of the driven shaft, that is, to turn on the reverse. Of course, it is also available on cars. The principle of operation of the reverse is simple. Another wheel is included in the gear system, which changes the direction of rotation of the driven shaft. Worm gears, a screw and an associated worm wheel are often used in gearboxes. These transmissions can be with a cylindrical worm or with a globoid. A cylindrical worm can have an involute profile or an Archimedes spiral profile in the end section. Archimedean worms are more widespread in mechanical engineering. According to the number of turns, worms are divided into single-turn and multi-turn. The cross-section shows that this worm is 4-turn. The gear ratio of worm gears is equal to the ratio of the number of teeth of the wheel to the number of visits of the worm. The advantages of worm gears are in obtaining relatively large gear ratios, in smooth and silent operation. With their help, self-braking systems can be performed, for example, manual hoists, where the angle of lifting of the worm angle is less than the angle of friction. The most progressive gears include planetary gear mechanisms. They consist of the following elements of the central solar wheel, satellites and a driver. In such mechanisms there are movable wheel axles. The number of satellites depends on the purpose of the mechanism. These wheels can have teeth of both external engagement and internal. The gear ratio of planetary gears is determined by the method of motion reversal. When suspended, it is equal to the ratio of the angular velocities of the central wheels, taking into account the speed of the reversed movement. Planetary mechanisms with two or more leading links are called differential. The advantage of planetary gears is that they are more compact than mechanisms with fixed axles. So, for example, the entire drive of the log loader movement can be placed in the motor wheel. If the gear ratio of the suspended was driven close to 1, then the gear ratio is 10,000, but the efficiency is very low. Wave gears were a further development of planetary mechanisms. The transformation of motion in them is carried out due to the deformation of the gear ring of the flexible wheel. Sometimes the drive or driven shafts, due to the design features of the machine, must be located at a considerable distance from each other. In this case, the torque can be transferred to the driven shaft using a flexible coupling. In the 19th century, belt drives in workshops were an integral part. The power source was a steam engine, one for the entire workshop, and the movement from it was transmitted to the machines at a distance using drive belts. Belt drives are also used in modern machines. Most belts are wedge-shaped, this reduces slippage. Step pulleys are used to change the speed of the driven shaft. The advantages of the belt drive are the comparative simplicity of its device and the ability to work with high circumferential speeds. The disadvantage is that with a small belt tension, it slips, and with a large one, the load on the shafts increases, the belt stretch and their service life is shortened. Belt drives are also used in variators. In our example, the sizes of the pulleys change. Drive belts made of new synthetic materials are increasingly being used. They are durable and can operate at high speeds. The gear belt transmission provides a constant gear ratio, does not require tension, and therefore reduces the load on the shafts and supports. The frictional principle of transmission is replaced by gearing here. But for the same purpose, chain transmissions are more often used. Drive chains can be of different designs. This is a bushing roller chain. It consists of separate links that are mounted to a given length. Chain drives can be single-row and multi-row. Their common advantage is that slippage and harmful loads on the shafts are excluded. When such gears operate in the absence of liquid lubrication, their wear accelerates. Multi-row gear chains are used in responsible mechanisms. They are more durable and work with less noise. Mechanical transmissions are very diverse. The choice of transmission type is determined by technological and economic factors.